Physics Practical Skills Video 1. The intentions of learning this is actually to develop a systematic approach to carrying out experiments. That means you need to describe how to plan, set up and investigate the results, investigating and analyzing the results, and writing conclusions. So these details you should be able to present in a way that the people can understand. So obviously you know that in A2 level you are not going to be discussing about you are not going to be doing it practically, but rather you will be discussing about how to do it. Then identifying dependent, independent and control variables using logarithms and logarithmic graphs, and combining uncertainties and extending the practical skills that you have learned in AAS level. So I suggest that you go through the AAS level practical part as well before you attempt this. Then you have to plot error bars on graphs, and then find gradients and uncertainties in gradients and intercepts. So these things you need to know. Then please go through the AS part, then you would be ready to do this. Now in the first part, that is in AS part, you have learned how to carry out different experiments, and the planning part, then analyzing and evaluation and reaching the conclusion part you have developed. Now this will actually work, add more things to this, and then from there onwards you will be able to add more skills and do more explanation to focus your understanding on different aspects of the practical, that is the steps that I told you earlier, on those separate parts, and then finally reach the conclusion. So now the first step is planning. Now how to plan an experiment is one thing that you will need to understand. The first thing that you need to do is you have to create this scenario in your mind and relate it with an equation that you are going to test. Now there would be a relationship. Now, for example, if you are going to let's take a simple example: force against momentum, the force and momentum relationship. Then you might have to take that relationship. If there is a direct relationship between the two, then you would have to consider them in a way that the formulation of the two sides, that is the understanding of one changing similar to the other, or when one increases the other increases, that scenario you should be able to understand. You should and also you should expect that result, and accordingly you will have to create the you have to plan your experiment. Then sometimes you have to prove an equation. So then you will have to relate that equation to the practical. Then you will be given some apparatus, and those would be mentioned, but sometimes you might know that there would be a better method. Sometimes you have understood and you have learned a better method, but with the apparatus that they have mentioned, you can't carry out the experiment. But still, you can't explain the experiment that you have in your mind. Now you will have to plan a different experiment to bring out the same results. So it might it sounds a little difficult, but it is not. Only thing is, you will have to focus on your final approach or final requirement. What is it that you are that you are planning to gain by doing this experiment is what you need to remember. Then when you plan out your experiment, you should be able to draw the diagram showing the actual apparatus that you are going to use. So then you need to pay attention to different things. The first thing that you need to pay attention is to the procedure that you are going to follow. Then the different measurements that you are going to take along with the instruments that you are going to use to take these measurements. So you have to have an understanding as to what you are going to measure. Now, for example, if you are going to find the number of moles of something, now this is related to chemistry, but still if you have to find the number of moles, then how are you going to, there is no apparatus called mole meter. So how are you going to measure the moles? By measuring its mass. So then you need to know how that is done, and you need to know how the conversion is done. Then what are the control variables? Then how do you analyze the data? Then also you have to mention about the safety precautions that needs to be taken. For example, if you are dealing with sodium, then you might have to take different precautions. Sometimes if you are taking heavy objects, or if a higher force is being used, or if you are dealing with electricity, if you are dealing with super powered magnets, then those things are very important in relation to the safety. So you will have to mention what safety precautions you are going to take and you have already taken. Then first thing that you need to do when planning an experiment is you have to define the problem. You have to identify what the problem is. Then when identifying the problem, you need to identify independent variable in the experiment, dependent variable in the experiment. That means dependent and independent variables we have discussed, and if you have any doubts, you will be able to understand what they are when we go along. Then control variables. The control variables, where they are the quantities that you are going to control or keep constant so that it affects at the same manner. It does not mean that you eliminate any other factors, but you need to control them or keep it in the same or regular level. Right? Now you might want to start, when you are talking about the experiment, you might want to start with a statement, a very clear and concise statement. You have to be short and sweet. Remember that you have to be short and precise. So that means you have to give the details with the least number of words as possible, and focus. I'm not talking about the explanations, but I'm talking about presenting these variables. Now they are saying, let's study through this example and see how independent, dependent control variables affect. Now they are saying the deflection of a balloon by a jet of air is shown in figure P 2.1. You need to plan an investigation to show that tan theta is inversely proportional to V squared, where theta is the angle between the ground and the string of the balloon, and V is the speed of the air hitting the balloon. You are unlikely to have seen this experiment before, but this should not concern you. So this could be an examination question. You have never done these type of experiments. You don't have to actually focus on the calculations. You do not have to focus on what kind of an experiment, or what are the principles applied in this experiment. What you need to follow is how to test this. What is the problem and how to test that. That is exactly what you need to figure out. Now let's see what we need to be careful about. Now the first thing is, what are going to be the constant quantities? That means the control variables. These are going to be the control variables, like we saw earlier, the quantities that are going to be controlled. You can think of many, right? Now for example, the total mass of the balloon, then the mass placed underneath, then the temperature, etc. You will be thinking about many, right? Now this when it comes to this particular event, the total mass is going to be definitely a quantity that should be maintained. But because this in this experiment we are not changing either of these things. We are not changing the balloon, we are not changing the mass that is hung underneath, as you can see in the diagram. So it's highly unlikely that it would change. So so as a result, we do not have to talk about the change, the obvious, but if they are not likely to change, we don't have to talk about them. So we have to think about the quantities that could easily change during the experiment if we do not take proper care. So then what we need to understand is one thing that needs to be or kept constant is the balloon should be deflected downwards if the angle is not right. Now, for example, apologies. If the air wasn't to hit like this, right? If the air was to hit like this, then it will get thrown downwards. Then if it was to hit like this, then it would this might snap, the string might snap. So you have to be very careful as to how it is going to be affected, right? So the direction needs to be kept constant, right? So that is one thing that you will have to think about, that needs to come to your mind. So how is this going to come to your mind? It is through practice. That is, you have to go through the past paper questions and think about how to do this thing. If you think again and again repeatedly, if you think how I can, what are the quantities that would change, then you will understand, with time, when you compare your answers with the marking schemes, you will understand that certain quantities need to be maintained and the others need to be changed, right? Then the balloon may warm up and expand in size, then more air will hit the balloon. So the surface area needs to be kept constant. So to keep the surface area constant, what do you need? You need to maintain the temperature. In the first one, what you need to do is to keep the because we are checking we will be, not the effect of the air speed will be changing. We will have to keep, that is what we are looking at, the effect of air speed. So then all the other things that changes that will have to be kept constant. So in the first one, to make it more constant, or to keep the effect of the jet of air to be constant, we have to make sure that the jet of air is always horizontal and hits the middle of the balloon. Then the temperature of the air inside the balloon should be maintained. So these things are very important. And also you need to specify that the temperature, when you talk about temperature, it is not the temperature on the moon. It is the temperature inside the balloon needs to be kept constant. So you have to, it is all about thinking about, this is practically thinking about real life situations and giving your answers, right? Now, keeping the length of the string constant is not important. It is not a primary concern for us. It is not a primary concern for us. It has to be maintained. But because we are actually talking about, we are not changing the length of the string, it doesn't become, it is an important one, but it is not as important as the other two we mentioned. So you need to take care as to what needs to be kept constant. I hope you understood. If you didn't understand, please ask questions. If you understood, please do question number 1. But before that, let's write down a note on this. An experiment involves planning, setting up of apparatus, investigating and recording results, analyzing data, and writing conclusions. When planning experiments, we need to first detail the independent variable, dependent variable, and control variables in order to identify the problem. Planning involves, leave a line and write, planning involves number 1, procedure to be followed. Number 2, measurements to be taken and the equipment used. Number 3, control of variables. Number 4, analysis of the data. Number 5, safety precautions to be taken. Leave a line and write. When the deflection of a balloon by a jet of air is to be seen, is to be checked. Now, for example, here what happens is, let me explain how this practical works. So the first, it would be like this. Now let's say helium is filled in the balloon. So it is a straight line. It is straight, attached straight, and it's up in the air. When you have a very small, air that is flowing at a very small speed, then it will get deflected somewhere like this, right? But with the higher the speed, it actually, if there is a very high speed, it would even go like this. So then the air should be directed in this direction. So it should always hit the middle of the balloon. That is what you need to, and that is something that you need to understand. Write down when the effect of a jet of air on the deflection of a balloon is to be checked, is to be tested by experimentation, we need to identify the independent variable, that is the angle theta. That is actually the theta is the dependent variable, because that is what changes. Speed is the speed of the air is the independent variable. Write down the first one, the independent variable is the speed v of the air, because that is what we change. What we change is the independent variable, and dependent on that, what changes is the dependent variable. Angle theta is the variable that changes, therefore it is the dependent variable, and the control variables are what we keep constant. When mentioning the control variables, we have to take care to mention the most important ones first. For example, in this particular situation, the jet of air being always horizontal and hitting the middle of the balloon and maintaining the temperature of the air inside the balloon are the most important. right? I hope I did not confuse you with the dependent and the independent variable. So the independent variable is what we change. So in this particular situation, because we are testing the effect of changing airspeed, so we change the airspeed. That is what we change. So that is the independent variable. Then what changes as a result is the theta angle. So as a result, that is going to be the dependent variable. I hope you understood. If you are confused, or if you did not understand anything, please ask me. Let me know, then I will explain it further. If you understood understood this part, please continue, do the question number 1.